The EduTech guys present a conversation from our live coverage of FETC in Orlando, Florida from Thursday, January 25th, 2018. Enjoy the program.
My name is Matthew Dillon. I am the lower school STEM Fab Lab Makerspace teacher at Ilani School in Honolulu, Hawaii.
Awesome.
Oh, man.
Aloha.
There you go.
It's
So
kind
you're
of a
not,
step down for you coming out to Florida. No, just kidding.
We don't have theme parks in Orlando or in
Oh,
Hawaii, so we
there
come
you
here
go.
for theme
there
parks.
you go. That's
Right.
right. Make the best of the situation.
Yes.
So tell us what you're doing at FETC.
Well, came for some conference time to get some new ideas. Also presented this morning on laser cutting and how to incorporate that with the curriculum, mainly in the lower school. And then I've got two poster sessions, one this afternoon and one tomorrow, just on Maker Ed and kind of the trial and error that we went through in creating our lab and things like that.
That's cool. That's really
yeah.
cool. Laser cutting, really cool stuff.
Yes.
I saw some laser cutters on the floor. We kind of get in at the end of the day there, and the stuff that it's interesting, and I want to say it's probably education that help push the boundaries of laser cutting.
Yeah.
And we do that in education and tech now. We push it, but so give us some insight on what you were talking about and what you're showing the other educators.
Yeah, I think the biggest thing, especially in maker education now, is it seems like it's the catchword. Everybody's talking about laser cutters, 3D printers, and that. But then schools get them and they don't know what to do with them.
Sure.
And how do they incorporate that into the curriculum? And I think that's the biggest thing. So getting that laser cutter used for something that you're doing in the class. So for example, one of the things we do with kindergartners is they used to make garden signs. And they make it on cardboard and put it on a chopstick, cover it with saran wrap and put it in the ground, and then the first rain or the first sprinkler would get wet and ruined. So when we started our lab 4 years ago, we said, well, why don't we have the kids draw their picture on a 3x5 card? We had a whole big process that we went through, but basically they draw their picture on a 3x5 card. I take it, scan it, send it to the laser cutter. We arrange the cutting lines around it, and we make a garden sign. So now they have that. They take it, put it right in the garden, and it'll last for the whole season.
That's awesome.
So just little things like that, introducing them to that all the way up through like 6th grade. We have at the end of the year a medieval fair. They're studying medieval times. So the kids will come in and they'll make swords and they'll make chessboards and all on the laser cutter. Amazing things that they do. And that's just kind of how we take them from the kindergarten through the 6th grade. And then for us, our upper school has laser cutters as well. And that we kind of introduce them to all the tech and the 3D printers and all that. So when they get to the upper school, if they want to take an elective in design and fabrication or Maker Ed or robotics, they have a lot of the background information that they need.
That's cool. So what are the processes involved for the students to learn before they laser cut? Or is there designing for laser cut?
Yeah, we actually talk about the design process and whether you think about design thinking from Stanford, or there's a group out of the Science Museum of Boston, EIE, education or engineering is elementary. Engineering is elementary, and they have a design process. So the idea is we just take the kids through that and introduce them and say, well, first come up with an idea. What do you want to make? Or what's the problem you want to solve? Or where do you want to go with this? Whether it's I need to make a box so Dad doesn't lose his keys anymore, or I need to find a way to make clean water when I'm on a camping trip. And then they, ask questions. Have other people done something like this? What materials can I use? What are the machines? Then they come up with ideas, and we just have them brainstorm different ideas. Then they evaluate those ideas, pick one, and then plan it out. So draw their design, list the materials, then they create it, and then they improve it if they have to and go around. So we teach that from kindergarten, whether it's, building a basic bridge with straws and Play-Doh, sticking it together. Well, what does a bridge look like? You've seen a bridge. Well, oh, it looks like this. Okay, draw what a bridge looks like. Now, could you make that with straws? And take them through that all the way up through the upper our 6th graders, where they're actually doing a lot of that design as well. And then once they get to upper school, they're doing even more of that, working with other classrooms, finding projects that they could help. We actually had a project that was done a couple years ago. Our wet lab was researching mosquito larvae. And every time they would go to try to get the iPad or the iPhone up to the microscope, the larvae would move. So that teacher challenged our design and fabrication teacher, could your kids design something on the 3D printer that would allow our kids to just have their iPad or iPhone? And it was a great relationship.
Yeah.
These kids, it was kind of like entrepreneurship. They had an audience or a client. They came back and forth with different ideas and eventually made a couple of different designs that fit iPads and 3D print or iPads and iPhones on the microscope. That were perfect. So when the little larva of the mosquito went through, they just had to hit the button. So that's kind of how we're doing it at our school.
That's really cool.
That's very cool.
So, technology-wise, for coding or for all of that, what applications do you take your kids through?
We also do, like with coding, we'll do a lot of Scratch.
Yeah.
We'll do our lower school science teacher does a lot of the we do. Our upper school, obviously, they have computer class, they have computer club, they have a robotics club, computer science, so app design, all those things. We go from basic all the way up. So our lower school, our kids will do different, I'm trying to think of what our computer teacher does with some of our real little kids. But we'll like I said, Scratch Junior.
Yeah.
We're starting to work with some of the older kids and with migrates like the 6th graders, just introducing Arduino and some of the things like that. Again, the idea is just to give them kind of an introduction to this stuff, so that if it's something that they really are interested in, whether it's computer science or design or fabrication, that when they get up to the upper school and they have the chance to take those electives,
They're prepped.
They're ready.
Yeah.
And so we found already now, our lab's been in existence for 4 years. We have kids now in 7th, 8th grade that when the teacher says, okay, we need you to start designing your pieces for your robot on Inkscape and use the laser cutter. Oh, we learned that when we were in lower school. Yeah. And so she doesn't have to teach those kids. She only has to teach the kids that are brand new to the school.
Oh, wow. That
came in that year. So it seems to be working.
Yes.
That's really awesome.
Well, I want to shift gears a little bit, and I want to hear your thoughts on, and I know this is something that you presented earlier in the week, but talking about designing learning spaces and get your input, get your feel. What are some of the things that you talked about? What are some of the feedback you got? That type of thing for that session.
We kind of, when we talked about learning spaces, for us, it's we had our lab specifically was kind of designed for us, the space. And then when it comes time to figuring out that space, I know a lot of the stuff that comes out of the D school in Stanford is great. We've used a lot of that, and that's one of the resources that we throw out there to people is it's got to be functional. It's got to be, user friendly, all those things you talk about. Giving kids the chance to, stand up if they need to stand up or sit down if they need to sit down, which kind of for us bridged back to our fabrication because we needed standing desks for our lower school, and they charged the design and fabrication class, and these kids using a bunch of CNC mills and things created actual standing desks for some of our lower school. So as far as designing the space, I think it's real specific to what your needs are.
Sure.
And I think that's the biggest thing. And then finding, if you're going out and you're buying desks or chairs or stools, it's finding what fits into what you've got as well as your budget and all that good stuff.
Yeah. Well, I think it's phenomenal that your school system is set up to where there's a problem that needs to be solved, well, really in any grade level, that doesn't matter. And you have a set of students and educators who are able to take that and at least make an attempt to solve that problem through the equipment you have, the skills that they have learned and are learning. Right. My guess is that the students learn a lot of that
all the time
as it's happening. We need standing desks. We're like, I don't know what's a standing desk. That type of thing. And in obviously in some cases they actually are able to produce a product that meets the need.
Right.
That is awesome.
And that's, again, our upper school is an amazing setup, but we've had people come in, and a couple years ago they made a stand-up paddleboard, and we have a group called I believe it's Access Surf. Don't quote me on that. I think they're with United Way, but they help people with physical disabilities learn to surf. And so I can't remember if we approached them or they approached us, but the idea was for us to design a stand-up paddleboard that would help accommodate people with physical limitations.
Yeah.
And we had a professor at the University of Hawaii who does bee research, needed some beehives for a special indigenous bee to Hawaii, and our design and fabrication kids came up with this specific. So it's an amazing. I besides being lucky to be in Hawaii, the school I work at is unbelievable as well.
You have like you have the cake. And
I'm
icing.
eating it. Yeah, and I'm eating it.
And you're eating it. Yes. That is awesome stuff. Man, thank you so much.
Oh, my
for
pleasure.
coming
Thanks for
by
having me
and-
down.
and
Yeah.
Nice
sharing
talking
your
to you
story
guys.
with
Well,
us.
and have a great FETC.
Oh yeah.
And
Love
we
it.
call it FETC, and we get in trouble for that. Sorry, FETC.
FETC.
Oh,
So, but before
But anyway,
you go,
well, first of all, how can folks that want to know more about what you're doing and what your amazing school is doing, how can they reach you?
My email is pmattdillon, Dillon, at iolani.org. It's IOLANI.org. That's a school email. And then from that, I can give them a link to my blog for the lab, our Twitter account, the upper school actually is sullivan.iolani.org. And that will take them to the upper school stuff as well. So that's probably the best way.
cool.
Awesome.
You've been listening to a recorded conversation from EduTech Guys live coverage of FETC 2018. For more information about EduTech Guys, visit edutechguys.com. And thanks for listening.